A recent statement by NASA's lead astrophysicist has caused shockwaves at some point of the medical fraternity. Betelgeuse, the enormous red supergiant star, is exhibiting signs and symptoms of unprecedented instability, which may mark its catastrophic downfall at any time. Astronomers have been guessing for years about when this cosmic giant would potentially go supernova. But now the James Webb Space Telescope has recorded information that indicates that the phenomenon may be approaching. Here's why this matters. Betelgeuse is so big and so close to Earth that its explosion would be observable even in the daytime, and its effects should reverberate throughout our solar machine in ways that we're best just starting to comprehend. More disturbing, the state-of-the-art images from the JWST reveal unusual infrared signatures, heat flares, and mass ejections, suggesting an acceleration within the big name's life cycle. Envision a night sky forever changed, with constellations broken and the potential for cosmic debris moving towards our area of space. Are we prepared for the aftermath? And why is NASA apparently more focused than ever on Betelgeuse as rumors intensify? One aspect is definite. If Betelgeuse supernovas in our lifetime, it can radically reshape humanity's knowledge of the universe and our part of it. Betelgeuse, the brightest and largest star in the night sky, is approaching the end of its existence. Its final supernova explosion is likely to redefine the laws of astronomy. What makes this even better super is the possibility of an asymmetrical explosion, where a massive outburst of electricity and matter can be expelled unevenly, creating shockwaves that can travel to nearby megastar systems. New data from the James Webb Space Telescope and the Chandra X-ray Observatory from NASA indicates Betelgeuse has experienced a mysteriously huge floor mass ejection, SMME, a feat by no means discovered at such a magnitude within a red supergiant. This SMME ignited over 1 billion times the energy of a sun flare, and its path reveals a frightening capability. A runaway burst of plasma and radiation could strike nearby celebrity systems. This situation poses dire questions. Might this wave destabilize the fragile balance of gravitational forces within our galaxy? Could nearby systems, including those with habitable zones, enjoy devastating consequences, plus destabilized orbits or heightened radiation exposure? They are not hypothetical suggestions, but urgent concerns which are riding on NASA's rekindled interest in Betelgeuse's conduct. Compounding the mystery, computer simulations show that if Betelgeuse indeed blows up asymmetrically, the debris region could prefer to grow unevenly, producing thick regions of interstellar material. These regions would potentially clash with different celestial bodies or perhaps intrude on crucial area exploration missions in the next few decades. What's perhaps most maximum about it is that nobody has any idea while this event will occur. The accumulation of unpredictable power surges suggests a ticking time bomb, but how close are we to explosion? If it occurs earlier than anticipated, what surprises could possibly the blast keep watch over that we're no longer equipped for? NASA's James Webb Space Telescope is not continually just gazing on Betelgeuse. It's reshaping the sport ebook on finding out deceased celebrities. What is NASA especially nicely geared up to deal with this capability cosmic occasion is the collaboration of up-to-date infrared power and get entry to worldwide collaborative know-how. This makes Webb the most convenient instrument capable of detecting diffused modifications that would mark the superstar's arrival explosion. Webb's ability to sense infrared radiation from deep space enables it to look through the gas and dust clouds enveloping Betelgeuse. Recent measurements have discovered abrupt spikes in strength levels and erratic fabric outbursts from the celebrity's core. This level of accuracy is one that traditional telescopes such as the Hubble frankly cannot achieve. NASA is using Webb's data to build forecasting models, hoping to connect surface mass ejections with the last stages of a supernova's life cycle. If all goes well, this will be the first time ever that astronomers should be anticipating a celebrity's breakdown with precision. Betelgeuse's explosion, while hundreds of thousands of light-years from the Earth, has implications of potential hazards to satellite creation and space travel. NASA is already in active collaboration with the European Space Agency, ESA, and various corporations to establish backup measures for managing increased radiation and capability interference with orbiting satellites on Earth. The cooperative effort is critical, given that without those safeguards, an unexpected supernova might put the whole range from GPS infrastructure to weather satellites at risk. Webb's advanced spectrography skills enable it to detect elemental contents within Betelgeuse's ejections. These values provide a live look at the starlet's instability and can determine warning signs missed by standard optical telescopes. This period, combined with NASA's far-out community, provides researchers with a 3D perspective of the changing phenomenon. If NASA's predictions are unsuccessful, humanity risks losing the first true chance to observe and take a gander at a supernova in its early stages, a loss that could put us behind our understanding of stellar evolution by many years. Despite Webb's developments, astronomers are all too aware that the unpredictability of stars such as Betelgeuse makes room for errors, and the timing for such an event remains speculative. Latest simulations based on recent discoveries by the James Webb Space Telescope keep an eye on that the star's eventual detonation as a supernova might prefer to have cascading effects achieving a great distance beyond the celebs. Experts caution that radiation from such an explosion would have the potential to cause magnetic storms on Earth, interfering with critical technologies such as satellites, strength grids, and conversation structures. Astronomers are anticipating that when Betelgeuse explodes, the outburst of overpower radiation and cosmic particles should temporarily reconfigure Earth's magnetosphere, leading to geomagnetic storms. These storms are similar to, but likely more powerful than, those caused by sun flares. For those industries that rely on satellite communications along with GPS, weather forecasting, and global internet networks, the consequences can need to cause temporary blackouts or compromise service globally. More disturbing is the possible threat to energy grids. A geomagnetic typhoon precipitated by a supernova ought to overburden transformers and cause enormous outages, especially in already vulnerable areas. If Betelgeuse's explosion occurs suddenly, the lack of preparation should render infrastructure buildings bare to undoubtedly catastrophic consequences. NASA and the European Space Agency already investigate preemptive methods, employing predictive statistics of the James Webb Space Telescope. These firms are developing better alert systems capable of filtering radiation spikes in real time. ESA has floated the inclusion of dedicated stellar burst shields on next-generation satellites, technology that would protect essential orbital infrastructure from surprise bursts of cosmic radiation. In the meantime, collaborations with private companies such as SpaceX are opening the way for resilient satellite constellations capable of robotically reconfiguring orbits to avoid radiation-rich regions. This partnership between the public and private sectors illustrates how area exploration issues are redefining global technology strategies. Alternatively, the knowledge we can learn from observing Betelgeuse's explosion should change the way we prepare for and react to cosmic events. By studying the materials crafted throughout the supernova, researchers might prefer to free new insights into methods the universe forms heavy metals such as gold and uranium, sources essential to higher era. This event can also provide crucial information to help expand future interstellar travel plans, such as shielding spacecraft from radiation in deep space. If the attempts at screening Betelgeuse fail, repercussions should percolate through decades of territory investigation, devoid of important indicators of warning signs and leaving planet Earth vulnerable to surprising cosmic effects. Despite our modern era, experts acknowledge the lack of known facts, furthering the implications of what lies ahead. The fate of Betelgeuse is more than just a scientific puzzle. It's a glance at the readiness of humans to explore the uncharted. Will this supernova uncover secrets that elevate us to the next tier of area discovery? Or will it expose weaknesses that put us back in reverse? Not accurately portraying Betelgeuse could wish to lead to missed opportunities to assemble for its ability to wreak havoc. Should the supernova cause unanticipated magnetic storms, strength grids global should buckle, leaving towns dark and destroying current-day infrastructure. Satellite networks maintaining global communications, navigation, and emergency response systems are capable of being knocked out, denying billions access to critical services. At worst, Earth's magnetosphere can temporarily dip, opening our environment to increased levels of cosmic radiation. While not likely to cause direct damage to life, this would speed up satellite degradation and affect future